Peanut butter. It's the simple, satisfying spread that's always in the pantry. For so many of us, it's the taste of childhood, a quick lunch, or the secret ingredient in a favorite dessert. We spread it on toast, swirl it into oatmeal, and put a dollop on apple slices without a second thought. But have you ever stopped to think about the wild journey that goes into one humble jar? Have you pictured the massive scale required to turn a simple groundnut into that smooth, creamy perfection you get at the store? It takes, on average, about 540 peanuts to make a single 12-ounce jar. Now picture the millions of jars people eat every year. The numbers are just mind-boggling, and the process is an industrial marvel. This isn't about your kitchen food processor. This is a story of mega factories running 24/7 with machinery the size of trucks and production lines that seem to stretch for miles. Today, we're going inside one of these giants to see the entire incredible process. We'll follow the peanut from the moment it arrives by the truckload to the moment it's sealed, labeled, and ready for your kitchen. This is how groundnuts become peanut butter. Chapter 1. The source, from farm to factory. Gate. Long before any machine starts humming, our story begins in huge, sun-drenched fields. The hero of our story, the peanut, isn't really a nut. It's a legume, like a bean or a pea, and it grows in a pretty strange way. After the plant's yellow flower is pollinated, a stem called a peg grows downward and burrows into the soil. Underground is where the peanut pod actually develops, which is why we call them groundnuts. These plants love warm climates, so you'll find massive farms across the southern United States and in countries like India, China, and Nigeria. When it's harvest time, a machine called a digger inverter pulls up the whole plant, shakes off the dirt, and flips it over to let the peanuts dry in the sun. A few days later, a harvester, or combine, comes through and separates the peanuts from the plant. The scale here is enormous. A single acre can produce enough peanuts to make about 30,000 peanut butter sandwiches. From these farms, an endless convoy of trucks heads to the mega factory. But not just any peanut gets an invitation. The peanut butter industry has a favorite, the runner peanut. Making up over 80% of all peanuts grown in the US, runners are prized for their uniform kernel size. This isn't just for looks, it's the secret to a perfect, even roast. If you have peanuts of all different sizes, some will burn while others stay raw. With runners, the factory can guarantee every single kernel roasts to the same golden brown, giving you a consistent flavor in every jar. As these trucks, loaded with tons of carefully selected peanuts, line up at the factory gates, their industrial transformation is about to begin. Chapter 2. Arrival and initial inspection. Arriving at the factory is a total sensory overload. You hear the low hum of machinery everywhere. Huge trucks dump their cargo into massive underground hoppers with a deafening roar. We're talking tons of peanuts cascading like a waterfall, a river of legumes that will feed the factory's non-stop appetite. A single factory can process millions of peanuts every single day. But before a single one enters the main line, it has to pass a tough quality check. Samples are rushed to an on-site lab where technicians test for moisture and, most importantly, for aflatoxins. That's a potential toxin from a mold that can grow on peanuts if they aren't stored right. The industry takes this very seriously, so this first screening is the most critical line of defense. Any batch that shows the slightest hint of contamination is immediately rejected. Once cleared, the peanuts face their next challenge, the optical sorter. This is where modern automation gets really impressive. The peanuts fall in a high-speed curtain through a chamber lined with cameras that scan every single nut from multiple angles, thousands of times a second. They're programmed to spot any peanut that's discolored, broken, or shriveled. If the camera sees an imperfection, or even a tiny piece of shell, a precise puff of compressed air blasts the bad nut out of the stream into a rejection bin. It happens so fast you can't even see it, but it ensures the river of peanuts flowing into the factory is almost perfectly pure. Chapter 3. The Great Cleanup, Shelling and Debris Removal. Even after that high-tech inspection, the peanuts aren't quite ready. They arrived shelled, but fragments of shell and other field debris can still be hiding in the batch. So, they head into a mechanical maze designed to get them immaculately clean. The journey starts at a machine called a destoner. The peanuts flow onto a vibrating screen while air is forced up from below. The lighter peanuts float downhill, but any heavier stuff, like tiny stones that were the same size as a peanut and fool the sorters, can't be lifted by the air. They stay on the screen and vibrate away from the mainstream. From there, the peanuts are carried up elevators and onto a series of vibrating screens, like giant multi-layered sieves. The top layers catch any big pieces of debris, while the peanuts fall through to a finer screen that lets any tiny particles, like dust or sand, fall away. All the while, powerful blowers and vacuums are sucking up any lightweight bits of papery skin or plant matter. This whole process shows just how obsessed these factories are with purity. And the leftover shells and debris don't go to waste. They're often sold as animal feed or even used as biofuel to help power the factory itself. After this mechanical obstacle course, the peanuts are finally clean enough for the most important step: the roaster. Chapter 4. The Crucible. Roasting for flavor. Welcome to the heart of the factory. The roasting room is a warm, cavernous space that smells absolutely incredible. This is where the pale legume gets transformed, where its raw, beany flavor deepens into the rich, nutty taste we all know and love. And it happens inside gigantic industrial roasters. While some factories use huge rotating drums, the most modern ones use continuous hot air roasters. Here, the peanuts ride a slow-moving conveyor belt through a long tunnel where they are blasted with precisely controlled hot air, typically held around 160 to 204 degrees Celsius. In these high-efficiency systems, the whole journey can take as little as 5 to 10 minutes. During this fiery ride, a beautiful bit of chemistry happens. The Maillard reaction. It's the same reaction that browns your toast or sears a steak. Triggered by the intense heat, it creates hundreds of new aromatic compounds, giving the peanuts their signature roasted flavor and golden brown color. A single roaster can process nearly 4 tons of peanuts every hour. To keep things consistent, sophisticated light sensors called photometers constantly measure the color of the peanuts. This data feeds back to a computer that makes tiny adjustments to the temperature or belt speed, ensuring every batch is roasted to the exact same shade. This step is everything for flavor. Under-roast them and the peanut butter tastes grassy. Over-roast them and it's bitter. Here, science guarantees perfection on a massive scale. Chapter 5. The critical cool down and blanching. The moment the peanuts exit the roaster, the clock is ticking. They are still scorching hot and will keep cooking, which could push them into burnt territory. To stop this, the cooking process has to be halted instantly. The peanuts spill onto another conveyor and enter a cooling tunnel. Here, huge industrial fans pull a massive volume of air through the bed of hot peanuts, a process called air quenching. This rapid cooling is critical. It stops the Maillard reaction in its tracks and brings the peanuts down to room temperature in just a few minutes, locking in that perfect roasted flavor. Once cooled, the peanuts move on to the blancher. The goal here is to remove the thin, papery, reddish-brown skins. While you can eat them, the skins add a slight bitterness and a gritty texture, so for the smoothest peanut butter, they have to go. How do you peel millions of tiny peanuts? Not with knives, but with friction. The peanuts are fed between 2 large rubber belts moving at different speeds. The gentle rubbing action rolls the skin right off without crushing the nut. As the skins are removed, a powerful vacuum sucks them away. But the blancher has another clever trick. The friction also splits the peanut perfectly in half, which exposes the little nub where the two halves connect. This is the peanut heart, or germ, and it contains compounds that can make the peanut butter bitter. As the split peanuts tumble out, they pass over a special grate. The large peanut halves glide over it, but the tiny, bitter hearts fall through the cracks and are collected. They don't go to waste either. They're often sold for bird seed mixes. With their skins and bitter hearts gone, what's left is the purest expression of the roasted peanut, ready for its final transformation. Chapter 6. The Transformation. Grinding into paste. This is the moment of magic. It's where solid peanut kernels finally become the smooth, flowing paste we know as peanut butter. This all happens inside powerful, purpose-built grinders, usually in a two-stage process designed for ultimate smoothness. First, the clean, blanched peanut halves are dropped into a primary grinder, often a heavy-duty mill where rotating steel hammers pulverize them at incredible speed. This does the heavy lifting, breaking down the peanuts and releasing their natural oils to create a coarse, thick paste. But for truly creamy peanut butter, that's not smooth enough. The coarse paste is immediately fed into a second, specialized machine called a colloid mill. The paste is forced through a tiny gap between a stationary disc and a disc that rotates at an extremely high speed. The intense shearing force in this tiny space literally rips the peanut particles apart, reducing them to an incredibly fine and uniform size. What went in as a gritty paste now flows out as a smooth, almost liquid, homogeneous fluid. The particles are so small that the texture is perfectly velvety on the tongue. This two-stage system is the secret behind that signature smoothness of store-bought peanut butter. It's wild to think that this whole industrial ballet, from the farm to the roaster to these high-speed grinders, is all for one simple thing: the perfect jar of peanut butter. The engineering is just astounding. If you're finding this journey as fascinating as we are, and you want more stories about how your favorite foods are made, make sure you hit that subscribe button and ring the bell so you don't miss our next look inside the world's most amazing mega factories. Chapter 7. The Perfect Blend. Mixing and Homogenization. What flows out of the grinder is pure, unadulterated ground peanuts, but it's not quite peanut butter yet. To get it ready for the supermarket shelf, a few more key ingredients are needed. The warm peanut paste is pumped into enormous mixing tanks with large, slowly rotating paddles. As it churns, the other ingredients are added. First, a little salt to enhance the flavor, then a sweetener like sugar or molasses, depending on the brand's recipe. But the most crucial ingredient is the stabilizer. For most major brands, this is a very small amount of fully hydrogenated vegetable oil. Why? Natural peanut butter separates over time. The oil rises to the top, leaving a dry brick of peanut solids at the bottom. The stabilizer prevents this, creating a matrix that traps the peanut oil and keeps the whole jar smooth and creamy. No stirring required. And just so you know, modern food science uses fully hydrogenated oils, which don't contain the trans fats that were a concern in partially hydrogenated oils years ago. For crunchy peanut butter, there's a clever twist. A separate batch of peanuts is only partially ground into small chunks. Those chunks are then mixed into the creamy peanut butter at the very end, so they keep their distinct crunch. Chapter 8. The Final Polish. Cooling, degassing, and packaging. The peanut butter is now perfectly mixed, but it's still warm and has the consistency of a thick liquid. To get that familiar, spreadable texture, it's pumped through a heat exchanger that cools it down, allowing it to thicken. During all that grinding and mixing, air gets whipped into the paste. To get it out, the peanut butter is spread in a thin film inside a vacuum chamber. The vacuum causes the trapped air bubbles to expand and escape, leaving a denser, smoother product. Now, for the final spectacle, the packaging line. This is a symphony of automation. Empty jars are sterilized with jets of air and then marched to the filling station. A rotary filler with multiple nozzles descends and injects the perfect amount of peanut butter into each jar, filling hundreds per minute. Immediately after, a foil seal is placed on the opening and heated, creating an airtight freshness seal. The plastic lids are then automatically screwed onto the perfect tightness. The sealed jars continue their journey, getting wrapped in their familiar labels at lightning speed. Finally, robotic arms pick up the finished jars and arrange them perfectly into cardboard boxes. The boxes are taped shut, stacked onto pallets, and wrapped for shipping. The whole process, from an empty jar to a pallet ready for a truck, is a seamless, high-speed ballet of robots and machines. From that pallet, the journey is almost over. Forklifts carry the boxes to waiting trucks, which will deliver the finished product to grocery store shelves all over the country and around the world. So the next time you twist open a jar of peanut butter, take a second. Think about the sun-drenched fields, the roaring roasters, the high-speed optical sorters, and the incredible power of the grinders. Remember the science that created its flavor and the clever engineering that removes its bitter heart. What starts as a simple plant growing underground is transformed by staggering industrial might, precision engineering, and food science into a staple in your kitchen. It's a journey of millions of peanuts and dozens of complex machines, all culminating in that one simple, perfect jar